Hey guys, welcome back to our segment routing traffic engineering series. In the last episode, we kind of learned about SR-PCE and how we can go ahead and start consuming SR-PCE, part of our SR policies. So far in this series, what we have covered, and if you recall, we had talked about very initially, whenever we create a dynamic path, there were two things about the dynamic path. There was an optimization objective and there were some set of constraints involved. So far, what we have covered in our dynamic path is the optimization objective. So we looked up different type of optimization objective like TE-based, IGP-based, latency, and we kind of went ahead and computed the path locally or from the SR-PCE. Going forward in this series, now we will be focusing on the other aspect of your dynamic path, which are simply the constraints. So constraint really talks about, okay, hey, when you are calculating a path, now you are adding certain conditions to that path calculation, and based on those constraints or conditions, now you want your SR-PCE to figure out a path from a given PCC or a head end to a given endpoint. And that's what we're going to go ahead and explore in this particular episode. So we will be focusing around the constraints. So let's go to slide number 65. That really talks about some of these constraints. I'm going to go ahead and skip through, and let's quickly go to slide number 65. And again, you can go ahead and download these slides from the segment-routing.net. Thanks to these guys again, putting such a wonderful material. So now that's what we had done. Now just quickly further scrolling down, the constraint. Yes, this will be the focus of this ongoing episode, or a couple of the episodes. We will be focusing around the different type of constraint, and we will see how we can go ahead and consume these constraints when we are creating the SR policy. So as it talks about, hey, there are different type of constraints. The following constraint can be specified. We can have a constraint to be included or excluded, and that applies to TE-Affinity, or TE, simply your traffic engineering affinity. Or sometimes people just simply call them affinity constraints also. We can do certain type of include and exclude of IP addresses. That also apply with the SRLG. We did the maximum metric, the metric minimization using IGPT and a delay, and some of the other things like a disjoint and all. So the very first type of affinity that we're going to go ahead and focus, it's simply called as a TE-Affinity, or simply called as affinity constraint also. So the whole idea behind this TE-Affinity is, hey, you want to have a policy where you want to avoid certain links. Let's say you are saying, okay, hey, in my policy I have a multiple path, and for some reason I do not want my policy to be taking certain path, and that's where we can go ahead and color. So we simply call them a color. So what we go ahead and do, we create an affinity map, and using that affinity map we will go ahead and start coloring our interfaces. And once the interfaces are colored, we can use the include or the exclude keyword with those certain colors, and we can specify them as a part of our affinity constraint or part of our SR policy. So that's where it says, okay, hey, link in the network can be colored. When we say colored, that means again we are assigning them a numerical value, and once the links are colored, SRT can compute a path that again include or exclude links that have specific color. Like again, let's say in your policy or in our topology, we have two paths. We can give one path one color and the second path another color. And when we are creating an SRTE policy, we can say, hey, always take this path to go to this particular endpoint, and that can be done with this whole thing. So that's what it talks about, when we are working with the constraint or the affinity thing. The very first thing that we need to do is to go ahead and create an affinity map, or simply sometimes it's also called as the affinity bit map. And that bitmap needs to be configured into the whole topology, guys. Again, just to reiterate, it needs to be configured on whole topology. And this affinity bitmap, or simply the affinity map, is being used by your IGP like ISIS or OSPF. And once your affinity bitmap is configured on all the routers in the topology, Now using that affinity bit map, we can go ahead and start coloring. That means we can go ahead and start assigning a numerical value to our interfaces. And once that is done, we can go ahead and create our SR policy. So if you really see, this whole affinity thing is divided in 3 steps, if I have to call. So the step 1 or the task number 1 would be, okay, hey, just simply go ahead and create affinity bit map across all the router in the topology. That is the step number 1. And that affinity map needs to be same on all the routers, because if you do not have same on some router, if you are saying, okay, my color X has a bit position of 1, and on the second router, if you go ahead and say, hey, for the same color, my bit position is different, that would have a different result into the policy. That is the reason when we are creating a bit map, we want to have the same bit map applied to all the routers. So all the routers are kind of, similar, and they follow the similar logic or give us the similar result that we are expecting. Once the bit map is created, now the second thing, we will go ahead and define color, and we will go ahead and start coloring our interfaces. And again, let's say if you're defining 2 color, that means we have multiple links, and we can give one link one color and the second link another color. Once the links are colored, now we can go ahead and create an SR policy and have either of those colors either included or excluded. So these are the 3 steps that we will go ahead and take a look at in this particular episode. So if I have to quickly look at over here, so in this case, let's go ahead and see here. It says add colors to link. So let's see what do we have here. Okay. So as we said, the step number 1, let's go ahead and step by step. So step number 1 would be creating an affinity map. So to create an affinity map, let's say in this, if you just take a look at this topology, in this topology there are 6 routers. And let's say the router 1 is interested in going to router 4. So if you take a look at this, router 1 has 2 possible paths. Either it can take the top path, that is the gig 0 interface, or the bottom path where there's gig 01. Now we want to go ahead and include or exclude certain links. That means we have planned to use affinity. So on all the routers, we will go ahead and create an affinity map. And to create an affinity map, we'll say segment routing traffic engineering. Once we are inside traffic engineering, we will go ahead and use a keyword that says affinity map. Hey, we are going to go ahead and create an affinity map, and that is also called as TE-Affinity Map or simply the affinity constraint. And now here we are saying color. We are giving a human user-friendly name. We are saying color is blue. And for the color blue is being represented by the bit position number 0 in this case. And again, you could have a different bit number if you want. We are defining another color in this affinity map. We are saying red, and red is being denoted by the bit position number 1. We are using the another color, which is green, and that is being denoted by the bit position number 2. So we have now an affinity map. In that affinity map, we have 3 colors: blue, red, and green. And all of these colors are represented by different numerical values. And now we just need to go ahead and create the same affinity map across all the devices in this whole topology. Now we'll go ahead and repeat the same configuration on node 2, node 3, node 4, node 5, and node 6. And once the affinity map is configured or defined across all the routers, now once we have our affinity map is done, that is mean the step 1 or task 1 is done. Now in our task 2 or step number 2, now we'll go ahead and define, or we will start coloring our interfaces on all the routers in this topology. And to define a color or to color an interface, we need to go under again segment routing traffic engineering, and we'll go ahead and pick the interface. In this case, we are doing this configuration on node number 1. So you can see on node number 1, we are saying segment routing traffic engineering. And under that, we are going inside. If you take a look at, we are inside the traffic engineering. Here we are saying interface. So this is the interface that we are picking, gig 000. And here we are saying affinity color blue. So that means this link we have just colored with a bit position 0. And the human friendly name for bit position 0 is blue. So we can call, hey, the link between node 1 and 2 is being colored with color blue. Now similarly, if I go ahead and take a look at in this example, the link between node 1 and node 6 has been colored. It has been assigned both the colors, blue and green. That means a link can have more than one color also. But let's say for the time being, assume that we have only assigned the color being green here. So that means the top link is blue and the bottom is green. Now we'll go ahead and repeat the same configuration node 2. You will come to node 2 and you'll say segment routing, traffic engineering. You will pick up the interface. Let's say the interface is gig 0 here. And we'll go ahead and say affinity color blue. So that means the node between the link between 2 and 3 is also being colored blue. Similarly, let's say the whole path we have colored blue. And imagine the whole bottom path we have colored as green. Now, once that is done, now we can go ahead and create an SR policy. Let's see if there is an example for that. Yes. So now we can go to the node 1 and we can create an SR policy by, again, usual thing, policy, a policy name. We'll go ahead and give a color to our policy. We'll provide our endpoint. And now if you take a look at under all of these dynamic and everything, we have using a new keyword which is called constraints. And in the constraint, we are just simply saying, okay, hey, affinity, that means we are using affinity. And here we are just simply saying exclude any. That means we are saying, hey, in this path, when the path is being calculated from node 1 to node 4, whenever that path calculation is done, make sure to avoid any link that has a color of red. And in this example, it seems we have the link between node 6 and node 5 happen to have the color being red. That means when the path is being calculated by local node or by PCE, it will go ahead and exclude this particular link. Once you exclude this link, that means there is no way for node 1 to reach via the bottom path to the node 4. So it will end up taking the top path. So that is how in an SR policy, we can go ahead and include or exclude certain links. So now let's quickly jump back onto the hands-on and we will take a look at some of these things in action here. So now let's go back to our topology. So in this case, this is the topology that we are working with. This is our head-end router that we are using, which is the router 1. And this is our router 10, which happens to be our tail-end router. And we have a SR-PCE redundancy. So if you take a look at on router 1, we have created an affinity map. So under segment routing traffic engineering, I'm using an affinity map keyword. And here I'm saying, hey, name red. The bit position for red is being denoted by bit number 1. A green, where the bit position is number 2. And an orange, where is a bit position number 3. That means on this particular router, we went ahead and configured a affinity map, and the affinity map has 3 colors, red, green and orange, and their affinity bit positions are 1, 2 and 3. And again, as we said, we need to configure the same affinity map across all the nodes. And if you want to really verify, let's come down to the node 10 quickly. So we'll go ahead and log into the node 10 here and show run segment routing traffic engineering. And as you can see, on this router also, we have an affinity map that is configured where we are saying the name is red, the bit position is 1, 2, and 3. And again, we can take a look at one of the intermediate routers also. So let's go to the router number 4 here and let's log in here. And if you take a look at on this router, we also have an affinity map that is being configured. Now our task number is 1. That means in this whole topology, we went ahead and configured an affinity map, and these are the bits that we have set in the affinity map. Now, after creating the affinity map, the second part was to color the interfaces onto our router. That means we need to go ahead and start coloring the interfaces. So let's say in this particular case, let me verify. I'll take a quickly look at the configuration on our router R2. Show run segment routing traffic engineering. And as you can see on this router also I have an affinity map, and on this router, okay, I am using gig interface 000. So let's go ahead and do that. Now let's come back to router R1. So on the router R1, if you take a look at, we have 2 interfaces, gig 0 and gig 1 really. gig 0, if I do simply a show run on interface gig 00, gig 0 is connected to our, if you see here, gig 0 is connected to router 2 and gig 1 is connected to router 3. So in this case, let's say the link between router R1 and R2, we want to color it as a red, and the link between router R1 and R3 we want to color as green in that particular case. So we can go ahead and do that configuration, and if you recall that, we need to go into what? Segment routing, traffic engineering. And the very first thing we'll say interface. We'll give the interface name, and followed by there are a couple things, and one of the things that we are interested is the affinity keyword. Affinity interface, affinity configuration. So we'll go ahead and say affinity, and if you do a question mark, it says, hey, tell me the name of the affinity that you want to use. And if you take a look at, these are the affinities that we have configured: red, green, and orange. And we are doing this configuration on interface between router 1 and router 2. So we'll go ahead and color this link as red. So now let's go ahead and call it red. This is done. Now let's come out of this thing, and now again we'll say interface gigabit ethernet 001, and we'll say affinity name, and in this case, let's say we want to color it as green. I'm going to go ahead and commit the change. I'll come out of the config mode, and if I'll just go ahead and simply do the show segment routing traffic engineering, and you can see on the step 1 we had created the affinity map. In the second step, we went ahead and colored our interfaces on this router. So in this router, we are saying, okay, hey, the link between node 1 and node 2 has been colored as red, and the link between node 1 and 3 has been colored as green. Now we can go ahead and do this coloring across all the routers. We can do whatever color you want. Okay. So in this case, we have done some coloring. Okay. Now let's say go ahead and we can now move to step number 3. The step number 3 is simply creating an SR policy. So when we're going to go ahead and create an SR policy, let's say I want to say, hey, do not pick the link that has been colored as red. That means we are telling our policy, hey, when the path calculation is done, do not go via node 2. Initially, you can go to node 3, and from node 3, you can pick any path, but we do not want the router 1 going via node 2. So we can go ahead and create an SR policy now, which is the step number 3. So we'll go ahead and say segment routing traffic engineering. And now we'll just simply go ahead and create a policy. Let's say I'll just call it pol1. We'll go ahead and give it a color. Let's say color in this case is 10. And we'll go ahead and give our endpoint IP address, which happens to be the loopback IP address of our router 10. That means we'll be going from this router R1 all the way to this router R10. And we have multiple paths that the router R1 can decide to take. Now, our usual part, we'll just say candidate paths again, and we'll go ahead and give a preference. And during the preference, now we need to go ahead and say what? Hey, dynamic, we'll say same PSAP. And if you come out after this, now we just did a PSAP, okay? Now, there are a few more things that we can go ahead and say metric, type, and the metric that I want to use, let's say in this case is IGP. We came out. Now, there is something we can go ahead under the preference path. I'm using a keyword that's using constraints. So again, if I take a look at constraint, candidate path constraint, that means the constraint is configured under the candidate path. That's as you can see here also that we are in the path and preferences here. So we'll go ahead and say, hey, the constraints. So if you take a look inside the constraint, we have quite a few things, and one of the option that says affinity, assign affinity to a path. So we'll say affinity here, and if I come down under affinity, there are a few things that I can go ahead and use with affinity. There is exclude group, exclude item, include all, include any, exclude any, and some of the other things that we can go ahead and use here. So in this case, we are saying, okay, hey, I do not want to use the link between node 1 and node 2. And remember, the link between node 1 and 2 we had colored as red. So we are saying, okay, hey, avoid the link that has a color red. So in this case, we'll go ahead and simply say exclude. And if you see with the exclude, we have an option that says exclude item, exclude any, exclude group. So we are saying exclude any. And with the exclude any, we can say the name. And what is the name? Hey, I want to go ahead and avoid the links which has a color of red for this particular policy. And that'll be all. Let's go ahead and commit our policy. And if you come out, let's quickly go ahead and do the show segment routing traffic engineering. And as you can see here, if I scroll down a little bit, and let me go ahead and scroll a little bit more, you can see on this router, we have an affinity map that was configured as step 1. In step 2, we went ahead and configured or colored the interfaces. So the link between node 1 and 2 was colored as red. The link between node 1 and 3 was colored as green. Now we created a policy based on IGP, and we are doing the path computation delegation to our PCE. We are looking with the keyword PSAP. But with that, now we have also specified constraint, because so far what we have been doing the optimization objective of the policy of the dynamic path. Now we have started using these constraint, and our constraint is very simple. We are saying, hey, do not take any link which has a color red. Now let's take a look at and see if our policy is up or not. Again, show segment routing traffic engineering policy. And in this case, you can see our policy is up, and the path was calculated by our first PCE 101, and the path is valid. It is based on IGP. And now, if you take a look at here, now we see another stuff here that says constraint. It says, okay, hey, this policy has constraint also, and the constraint type is affinity. In the affinity constraint, we are excluding any link that has a value of color. And that is why now you can see on the node 1, when the node 1 needs to reach the node 10 using this policy, the very first hop that is going to take is 16003, which happens to be the prefix set of our router 3. That means we are avoiding the link between node 1 and 2. From router 3, it is going to router 4. After 4, it is going to 7. And after 7, it just says, okay, I'm going to go to the 10. So as you can see, our policy has successfully avoided any links which were colored as red. And that is how we can go ahead and start using our constraint, or in this case, the affinity constraint. There is one thing that you need to keep in mind. Exclude will just exclude on the whole path if there is any link which is colored red. When you're working with include, and especially you say, let's say include all, you need to make sure that the whole path has that particular color. Otherwise, when you are trying to say, hey, include all, and if any of the link has a different color, it will fail. That means your policy cannot satisfy, because not all the links have that same color. So that is the only thing that you need to keep in mind when you're working with especially the include all. But that's why most of the time when we work with these policies or the constraint in production, majority of the time you will see exclude as the predominant used, across the policies versus using the include. Yeah, you can go ahead and use include. There is no harm, but that's what most majority is being used, the exclude. Again, just to quickly go over, there are 3 things that before you work with the constraint, and especially the affinity constraint, we need to go ahead and create an affinity map. And that affinity map needs to be configured on all the routers in your topology. So all the routers honors that particular affinity map and those bit position. Once that is done, now we need to go ahead and start coloring our interface with those respective colors. And once that is done in step 2, in the step 3, when we are creating a policy, in the policy now we'll go ahead and make use of the keyword constraint and the type of constraint you want to use. In this case, we were using affinity, and we just simply said, okay, hey, exclude any link that has been colored with color red. And that's how, guys, we can go ahead and make use of these colors. And again, there's the second thing in our policy when you're working with, after optimizing objective, it is all really about the constraints. And we just went ahead and took a look at the affinity constraint or traffic engineering constraint. So that'll be all for this particular episode. I will see you guys in the next episode. Thank you.